Okay, so we are going to go through exercise 5b, which is all about substituting and equivalence. Our learning intentions: to be able to substitute values to evaluate algebraic expressions, to understand what it means for two expressions to be equivalent, to understand how the commutative and associative laws for arithmetic can be used to determine equivalence, and to be able to show that two expressions are not equivalent using substitution. So the very first thing that we're going to go through in this lesson is substituting a pro numeral. So here we have the question: given that t is equal to 5, evaluate the following. So if t is equal to 5, what that means is I'm going to take that 5 and I'm going to put it into the t spot. So think of this as like a sporting match. You're substituting in one player for another. So in this case, we're substituting t out and we're putting 5 in. And that's because t is equal to 5. So we're going to end up with 5 plus 7. And now we're going to evaluate this. 5 plus 7 is equal to 12. And that's our answer. Let's now move on to the next one. So here we have 8t. So again, we're going to take this 5 and we're going to substitute it into this. Now, the way that we write this is we put the 8 and then we put the 5 in brackets there like that. Now, we know what's happening here. This is 8 times 5, and 8 times 5 is 40. So that's our answer. And you actually don't need this step. You could just go straight from this step to that step. So you don't need that step in between. Okay, let's keep on going. So here we have 10t plus 5 minus t. So again, what we're going to do is we're going to rewrite it and substitute in this 5. So I'm going to put a 5 in there, plus 4 minus 5. Now, this first step here, this step 1, is very important. Step 1, whenever you've got a substitution question, should always just be substituting in what you know. Normally, this is 1 mark. So 1 mark for simply substituting in. So your first step is always just subbing in what you know. Then start evaluating. 10 times 5 is 50. Then I'm going to put plus 5 minus 5. So as you can see, I've just rewritten that. 50 plus 5 is 45. 54. Sorry. 50 plus 4 is 54 minus 5. My final answer is going to be 49. So as you can see, I'm just systematically working through the question, making it easier and easier for me each time. Okay, let's go through the next one now, which says given that u is equal to -3. So what that means is I'm going to take this -3 and I'm going to put it into the u spot. So I'm going to get 4 -3. Now remember, that's 4 times -3, which is going to be equal to -12. So that is going to be my answer there. And remember, you can go straight from there to there. You don't need this middle step here. Okay, let's move on to our next one. So here we have u is equal to -3 and 3u minus 4. So I'm going to rewrite that as this. 3 times -3 is going to be -9 minus 4. -9 minus 4 is going to be -13. Let's go into this one now. So again, remember your first step is simply subbing in this u is equal to -3. So it's going to be -2, -3, plus 12, -3, minus 3. This is going to be, okay, this is important, -2 times -3. Because I'm multiplying two negative numbers here, my answer is going to be +6. Now I've got 12 over -3, so that's going to be -4 here, because remember, when you're dividing a positive and a negative, your answer is going to be negative. Then I'm going to -3 here. Now, this can be written in a simpler way. If I'm plussing a negative, that's the same thing as simply subtracting that value. So I'm going to end up with 6 minus 4 minus 3. Now, 6 minus 4 is going to be 2. And 2 minus 3 is going to be -1. And that's going to be my answer right there, -1. Okay, let's keep on going now, and let's just do some more examples. So you might want to pause the video and just see if you can do this for yourself. Alright, so we're substituting in x is equal to -2 and y is equal to 3 to evaluate these expressions. So to do this, how are we going to approach it? So I'm simply going to sub in my values that I know. So in this x spot, I'm going to put in -2. In the y spot, I'm going to be putting in 3. And see how I'm writing it there. I'm not putting in that multiplication sign. I'm rather just putting them both into brackets. And this is the convention as you go through high school. minus 4 plus, now y is 3. Negative 2 times negative 3 is going to be negative 6 minus 4 plus 3. Negative 6 minus 4 is going to be negative 10 plus 3 is going to be negative 7, and that's going to be my answer there. Let's now keep on moving to our next one, which is going to be 12 over, now x is going to be negative 2, then I'm going to have a minus, then I'm going to have 10, then I'm going to have negative 2 plus negative 2, then here will be 3. So be careful with your brackets, that's what it should look like. 12 over negative 2 is going to be negative 6. Remember, when you're dividing a positive and a negative, your answer is going to be negative. Then I've got this negative sign. 10 times negative 2 is going to be negative 20. Then I'm going to have plus negative 2 times negative 2 times positive 3 is going to be negative 6. Now remember, when I'm subtracting, or when I'm plussing a negative number, that's the same thing as subtracting it. So I'm going to end up with this. And now I'm going to go, this is negative 6 minus, this here is going to be negative 26. And now, when I've got two negatives right next to each other, it becomes a positive, and I'm going to end up with that, which means my final answer here is going to be just 20. So that was quite a tricky question just because of all the negatives, but remember, that's a skill that you need to make sure that you're on top of, that you can work your way around those. Okay, let's keep on going now. So now we're going to continue substituting, but this time we're going to see how powers and roots come into play here. So yet again, we're told that p is equal to 3, t is equal to 4, evaluate these expressions. So for this one right here, what I'm going to do is I'm going to take this value right here, because p is equal to 3, and I'm going to substitute it in like this. 3 squared is equal to 9. So this is 3, 9. 3 times 9 is 27. So 27 is my answer for the first one. Next, I'm going to take my t value, which is 4, and I'm going to square it, plus my p value, which is 3, and I'm going to cube it. 4 squared is 16, plus 3 cubed is 27. So now I just need to do 16 plus 27, which is going to be 43. Next, we come here. So again, I'm just going to sub in my values. Remember, subbing in should always be your first step. You always get a mark for just subbing things in. Even if you don't evaluate it correctly afterwards, you'll get a mark just for this step right here. 3 times 3 is 27, minus, this will be 2 over 2. The square root of 4 is 2. This is going to be, if I've done this correctly now, whoops, what have I done wrong? Whoopsie daisy. See? Actually, let's go back to this step. So I would have gotten a mark just for this. I went 3 times 3 was 27, which is, it's not true. 3 times 3 is 9, minus 2 over 2. That's better. Now I'm going to get 9 minus 2 is 7 over 2. That's going to be my answer, because I can't simplify that anymore. But remember, you'll get a mark just for this step. You'll get a mark just for this step. You'll get a mark just for that step, just for subbing things in. And if you do make a silly mistake, as I do sometimes, you'll still get that mark just for subbing in correctly. And subbing in is pretty easy. All right, here, substitute in x equals negative 3, y equals 2, and z equals negative 3 to evaluate the following. So here we have it right here. Let's give it a go. So x is negative 3, z is negative 1, plus x is negative 3, plus 6, and then I'm squaring that. Now negative 3 times negative 1. Now I'm multiplying two negative numbers there, so my outcome is going to be positive, plus, now here is just negative 3 plus 6 squared. Negative 3 plus 6 is going to be positive 3 squared, and 3 squared is 9. 9 plus 3 is going to be 12. So my answer to that one is going to be 12. And as you can see, there was quite a few steps. You just have to be careful with it. Okay, this one right here is going to be 30 over, now x is negative 3, minus 2, y is 2, close the brackets, open the brackets, x is negative 3 plus 3. Okay, so 30 over negative 3 is going to be negative 10 minus 2 times 2 is 4. Open my brackets. Negative 3 plus 3 is 0. 4 times 0 is just 0. So that means that this whole thing is just going to go away. I'm just going to be left with negative 10. Because negative 4 times 0, the whole thing goes away. Okay, let's keep on going. So now we have our last one here. So let's just make sure we've got that. So this is going to be 4. This is going to be negative 3. Y is going to be 2 over 2 minus 8 over Z is going to be negative 1. Now, negative 3 times 2 is going to be negative 6. So this is going to be 4 negative 6, 2. Now this right here, this is 8 divided by negative 1. So my answer is going to be negative 8. And now, let me do this first. I have 4 times negative 6, which is going to be negative 24 on 2. And then I'm going to have minus negative 8, which is going to be plus 8, because the two negatives cancel out. Then I have negative 24 over 2, which is going to be negative 12 plus 8. And that means my final answer is going to be negative 4. Perfect. Hopefully you found all of that manageable. There's quite a few steps there, but you just got to be careful with it. Okay, so the last part of this chapter is talking about equivalence. So let's read this very important statement here. This statement says, two expressions are equivalent if they are equal values. Sorry, let's start again. Two expressions are equivalent if they have equal values regardless of the number that is substituted for each pronumeral. The laws of arithmetic help to determine equivalence. We have the commutative laws and we have the associative laws. So let's just quickly run through what these laws tell us. The commutative law tells us that if we have a plus b, that's the same as b plus a. So let me give you an example. If I have 1 plus 2, that's equal to 3. Well, that's the same as 2 plus 1, because 2 plus 1 is also equal to 3. Let's come over here. The commutative law also tells us that 1 times 2 is equal to 2 times 1, because 1 times 2 is 2, and 2 times 1 is 2. 1 times 2 is 2, 2 times 1 is 2. The order does not matter. The associative law tells us something similar. What the associative law tells us is, well, let me give you an example here. Let's make a equal 1. Let's make b equal 2. Let's make c equal 3. If I was to solve this, I would get 1 plus 2 plus 3 is 5, 1 plus 5 is 6. If I was to now put in the same values, so a again is going to be equal to 1, b is going to be equal to 2, and c is going to be equal to 3. I'm going to get 1 plus 2 is 3, plus 3, 3 plus 3 is 6. And as you can see, 6 equals 6. So even though I've associated these together, and over here I've associated these together, it does not matter. I still get the same answer out, and this is something true for addition. And the same thing can be said for multiplication. So if I was just to quickly run you through this, using the same numbers and the same principle, so I'm doing this. Okay, I have 1 times 2 times 3 is 6. And over here, I have 1 times 2 is 2 times 3. Well, 1 times 6 is 6. 2 times 3 is 6. 6 equals 6. So there you go. So as you can see, our commutative laws and our associative laws have to do with addition and multiplication. Addition and multiplication. They do not apply to division and subtraction. That's very important. Okay, let's now answer these questions. For the following, state whether they are equivalent or not. Hint, substitute in numbers for help. So we're going to substitute in numbers for help here. So if I have p plus 3 and 3 plus p, we immediately know based on our commutative law, so you might even want to write that in. Our commutative law tells us that these two things are going to be equal to each other. P plus 3 is going to be equal to 3 plus p. So we immediately know that these are going to be equivalent based on our commutative law. But we could also double check this by letting p equal 1. If p is equal to 1, I'm going to get 1 plus 3, which is 4. And then on this side, I'm going to get 3 plus 1, which is also 4. So it checks out. Let's come over here. Now, we know that there is no commutative law for subtraction, so we immediately know that this is not going to work. So we could put an n here. It's not going to work, but we could also double check it. Let's let x equal 1. If x was going to be equal to 1, so x minus 3, I would get 1 minus 3, which is going to be negative 2. And then if for this one, 3 minus x, I would get 3 minus 1, which is equal to 2. Those two things aren't equal to each other. So none of these things are equal to each other. So that's how we can use substitution to double check what we're doing here. So these two statements are not equivalent because they give us different results out. All right, let's keep on going here. So again, the way that we can test whether or not these are equivalent or not is by subbing in a value. So let's let a equal 1 and b equal 2. Okay, so I have a plus b, which would be 1 plus 2, which would be 3. And then on this side, I have b plus 2a minus a. And for this one, I would end up with 2 plus 2 times, well, let me write it out like this, 2 times 1 minus 1. Okay, so this is going to be 2 plus 2 minus 1, and that is going to be equal to 3. So that's going to be equal to 3. So these are equal, so therefore these must be equal. These are equivalent. Another way to think about equivalence, which we're going to go through in our next lesson, is by merely recognizing that if I have 2 minus a, that's the same thing as just a by itself. But we're going to go into that in the next lesson, and we'll be seeing how we can use algebra to figure out equivalence, but let's not worry about that for the time being. Okay, the next one here, let's again use our substitution knowledge to answer this. So let's let a equal 2. If a is equal to 2, for 2a plus 3, if I put 2 into that spot, I'm going to get this, which is going to give me this, which is going to give me that. Then over here, I'm going to get this. So let me write it out first. 2a plus 6, which is going to give me 2 plus 6, which will be 4 plus 6, which will be 10. So as you can see, they're equal. So these must be equal. So these must be equal. So these must be equal. So therefore, this is equivalent. Perfect. So we have seen here how we can use our commutative law and associative law to figure out whether things are equivalent, and also how we can use our substitution knowledge to do so also. If we come back to our learning objectives at the very start of this lesson, let's see if we can do everything here. Are we able to substitute in values to evaluate algebraic expressions? Yes. Do we understand what it means for two expressions to be equivalent? Yes. Do we understand how the commutative and associative laws for arithmetic can be used to determine equivalence? Yes. Are we able to show that two expressions are not equivalent using substitution? Yes. Hopefully you found this lesson helpful, and I'll see you in the next one.